even see myself in my little camera thing. It's kind of fun to watch myself. Okay, what's up guys? So, today we are going to continue investigating this model for thermodynamics. We're really trying to get a full explanation here. Hopefully we'll get an explanation for a lot of different things. The question we're specifically looking at today is, does this only work with reactions? Does that temperature change only happen in a chemical reaction? So we need to look at a physical change where we have components that are starting at the same temperature, and then see, does it change temperature when these components interact without a chemical reaction? So keep that in mind. I've already shot the video for doing the experiment. I've got a document that'll be uploaded to Google Classroom. That document, you'll be able to pull that for your assignment, and then you'll be able to fill it out yourself and then turn it back in. It should be a very straightforward process. I'm also going to make an account for myself as a student in the classroom, so I can make a video showing you what it will look like from your perspective. Okay? Cool. So we're answering this question. My first step is to get water in each beaker. In one beaker, I'm putting 50 milliliters of water. Ooh, right on the money. Second beaker, I'm putting 100 milliliters. That was very good. It doesn't really have to be that exact. I just got lucky with it. Okay, so there's 50, there's 100. My ammonium nitrate is going to go into the 50 milliliters. So let's get some of that measured out. There we go. Good 10 grams. So, I've got my 50 milliliters ready to go. I've got my thermometer ready. I'm going to first take the temperature of that, which should be right around the same as room temperature. It's not really changing. So that's about 22 degrees Celsius. So I'm writing down, you can't see it, but I've got a board over here where I'm writing down 22 degrees Celsius for my initial temperature. And now I add my ammonium nitrate. Right around 12, okay. So we've got 12 degrees as our final temperature. So we lost 10 degrees Celsius. 10 whole degrees. It's not bad. Okay. Let's set that aside. Wipe this off. And then I needed 11 grams of potassium hydroxide. So let's just add one more gram to this. Probably should have been wearing gloves, but you know. Okay, so we want the initial temperature of this one as well. Give it a little bit of time. And it should be good, 22. It should be the same. There shouldn't be any difference. Initial temperature is 22 degrees Celsius. Now, if I know it's going to be 22, why would I check it? Well, there could be something going wrong with the thermometer. There could still be that dissolving reaction happening here. And if it was colder than my other initial temperature, then that would tell me, hey, I need to actually make sure I clean this off a little better before I start. Because otherwise I'm going to get a false reading on my final temperature. So it's less about double checking that, yeah, the room temperature didn't change, and more about making sure my thermometer is ready to go again. So let's dump this in. We're currently at 33 degrees. Let's see if it goes up anymore. Just give it a little bit of stirring action here. We're holding steady at 33. Okay. So with the ammonium nitrate, we went down 10 degrees. With the potassium hydroxide, we went up 11. Interesting. Okay. So now I'm going to clean this up, and let's analyze those results. So, I've attached a document. It should have a table in it, a space for observations, and a space for questions. You guys will be responsible for filling those out. So, obviously, I did it for you. We've already got our temperatures written down. This is going to be, so you'll just fill this out in the table. This will be 22 degrees for our initial temperature. That's Celsius, 22 degrees Celsius. And if you don't know how to make that little symbol on your computer, you can just leave it off and just put a C for Celsius. Is that good? Okay. I'm going to put it up there though because I'm writing it. Okay, and that was our temperature initial. This little I down here, it's called a subscript. It means initial. Whenever you see a variable in science or math with a little I there, that's what it's going to mean. Temperature final, F for final. For the NH4NO3, the ammonium nitrate, that's going to be 12 degrees Celsius. For the potassium hydroxide, the KOH, it's going to be 33 degrees Celsius. All right. Now, each of you will be responsible for coming up with 3 observations and 3 questions. An observation could be, Chesky forgot goggles. Hey, look at that. There we go. Now no one else needs to make that observation. A question could be something like, why does Chesky suck at safety? Hey, look at that. But really, let's try and have our questions be a little more related to the actual experiment. Okay, thank you.